Hello again. I've been here in this beautiful science lab on a Friday afternoon for 4.5 hours now, and the potato cells have been soaking in their sugar concentrations of different molarities for about 3 hours now. So let's have a look at what we can do in order to work out the percentage change in mass. Now we're using the percentage change in mass rather than just the change in mass because they all started off at different masses. They're all pretty close. They're around about 5.588 and the biggest is about 6.261. So they're all pretty close. They're in the upper 5.9s to 5.5s to 6.2s. But that's enough of a difference to affect the results. So we're going to look at the percentage increase or decrease in mass. So I won't do all of them, but you might have wondered why I did 3 for each molarity. And that's of course because one might not work. It might be an anomaly. So I want to be able to have 3 checks for exactly the same situation. I've kept everything else the same. They should be around about the same percentage for each molarity, but who knows? So think about what happens in osmosis while we do some of the results. And I'll only do 1 of each molarity. In fact, I don't even know if I'll be able to do the lowest molarity, water, because I might not be able to get the potato out of there. So I'm starting with this one, which is in the 0.1 molar. Right, so I get a beaker, get that out. It doesn't want to come out. I pat it dry, just roll it about on here. Then I measure it, zero it, put it on there, and it is now 60.82 grams. Right, 60.82, what? Hang on, what was it? 6.082 grams, that's a bit better. It's got bigger. I didn't expect that. This one in 0.1 molar was 5.994. There we go. Towel it dry. 0. 6.077. Very similar. And this one finally. Oops, I said I was only going to do 1 from every molarity, didn't I? I lied. And that will be, take that off, 0 that, and here we go, 6.140. Let's try in the pure water. Let's see if I can actually get this one out. So this one was 5.745 grams. Here it comes. Yes! Here it goes. And, whoops, take that off, and 0. 0. It was 5.745. It's now 6.104 grams. So what I want to do now is to look at how to do these calculations. I'm going to end up with 1, 2, 3, 4, 5, 6 threes are 18 measurements. And to do that with you on this video would just like try your patience a bit. So let's have a look at this. The initial mass equals 5.745 grams. The final mass is 6.104 grams. Okay, that's pretty clear. So the first thing I have to do is find the change in mass, which is of course final mass minus initial mass. And that's 6.104 minus 5.745 equals 0.359. So that, I'll just put my working here. So it has, let's see, increased in mass by 0.359 grams. But I want to find out the percentage change in mass. And the percentage change in mass is the change in mass over the initial mass times 100. So the percentage change in mass, 0.359, over the initial mass, which was 5.745. And when I find the quotient of that, when I've divided that, I'll multiply it by 100. So 0.359 divided by 5.745 equals 0.0624, and I multiply that by 100, and it is 6.25%. So all I did was find the initial mass and the final mass. Took away the initial mass from the final mass to work out the mass change. In this case, it was an increase of 0.359 grams. Then to find the percentage mass increase, I did the mass change, which I just worked out, plus 0.359, I think it is, yeah, and divided that by the initial mass, 5.745 grams, and then the quotient of that, the result of that division sum, I converted to a percentage by multiplying by 100. So that's what we're going to do with all of our results. And when we've done those, we're going to graph them, which will be fantastic.